All right. So yeah, how we created a monorepo for our webs at QuizUp. So the pain points of having like multiple projects for every project, or multiple repositories for every project that you have, is that every project is sort of a representation of best practices when it was first created. And that doesn't get updated a lot. So you have like, we, for example, had 5 projects. And we had a different setup phase for every repository that you cloned. Our deployments changed. First we had scripts, then we had like CI, which was a GitHub plugin for Jenkins. Then we had Jenkins files with auto deployment, and this doesn't get changed in the older repos. It's just better in the new things. And what this does is that code rots in old projects, and no one wants to touch them because no one knows how they work anymore. Or even the developer who first did it, he doesn't work here anymore. So literally no one knows how it works anymore. And another thing is like, you do all of this duplicate code. You have a boilerplate for your server, and it's always the same, but you have to duplicate it to all the places that you're doing a new web. And then you update how service discovery works, and it doesn't get updated because no one does. And then the worst thing about this all is updating dependencies. Our first React project was built in 2014, and since then there have been 26 releases of React. And no one ever thought about updating the editor because no one was working on it. So we wanted to change this because we don't like this. Like going back to our web client now, that's quizup.com, no one actually wants to work on that project because it's not the new thing that we're using today, and it's not as up to date. Late last year or early this year, I can't remember, we started doing a monorepo for our server code. So we decided to use like Scala and Java for most of our things, and there was this tool called Pants that does, it's like a build framework or build tool that helps you put all of your code into one repository, and then you have one command to run everything. So if you want to work on the feed, we just do pants run feed, and it runs locally. And the same for comments or games or whatever. All of our server code is just in one place, and it's the same command to run everything. And you only need to set up one repo. So this gives you the same structure for every project. So if you're going to work on, I'm going to work on adding, you can now post pictures to the comments. So I have to edit the comment service and the attachment service and maybe the web or something. And now all of this code is in the same place. So I don't have to have synchronized PRs and synchronized deployments and everything synchronized. It's just all in one place. So, and also what this gives us is now we run a lot of our things in Scala, and we run Finnegal. And if Finnegal updates, we just bump that one dependency in this one project, or this one repository, and it will automatically deploy 90% of QuizUp, and we don't even have to touch it. We just merge the pull request and everything goes out. So it gives us like a single setup, and code sharing is automatic because now if we have, for example, a player, which is a core element to our infrastructure, if I'm now going to call the player service and get a response, we have all, like in Scala you have type safety, but now I can use the same model that the player service is exposing. I can use that in my other service that's calling the player service. So I don't have to duplicate my player object all over the place. And this was like our motivation to do the same thing for the web, because we have a full stack team, so we work on both server and web code. And we hated that the server code was nicer to work on. We wanted the same thing. So we wanted to go from this over to this. And how we did that was, we thought about using Pants, because we used it in the server monorepo. But the Node construct module for Pants isn't really good. And we weren't willing to sacrifice any of the developer experience we had already. So we had like a developer experience with Webpack and Babel and Flow and ESLint and all of these things. And we had hot reloading, and we were not willing to sacrifice any of these. And NPM is a great package manager, and we were definitely not willing to sacrifice that. And how Pants does it is, you have to define your dependencies in their ecosystem, and then they install it for you. And we didn't want to go there. So the first thing we did was we were inspired by pants, so we created a dependencies.js file, which looks like this. This is the dependencies.js for our server in Jarvis. And as you can see, it depends on Express and Lodash and a lot of other stuff. And then it depends on our shared code, which is down here. So it depends on our shared API and a shared server. So now we have all of this boilerplate code, and it's defined in a shared folder, so you can just include it in your project. The next thing we did was we created JavaScript scripts for task running. So we now have 4 projects in this monorepo of ours, and this is what the scripts part of package.json looks like. We only do like dev or test or whatever, and then we give it the --s and say the name of the service. So our task runner he accepts a shell command, which is a template string, and then he reads this parameter .s and exchanges the name of the service that he wants to run, for example, tests for. And then the last thing we did was we created CI scripts, because we don't want, like, if I change something in the Jarvis project, I don't want all of our services to deploy, because that's just, it's unnecessary and it takes a lot of time to deploy everything. So we created CI scripts, and you can ignore the shell scripts, they're just because Jenkins doesn't know how to run Node. But we have a script here called change targets, and that's sort of the heart of our monorepo here. Change targets does sort of 4 things. It starts off by finding all dependencies.js files in our repository. It creates a full map of every dependency that is in this repository. So we can look up, if Jarvis has changed, we can look up all the things that Jarvis depends on and see if something there has been updated. For example, a package update in npm. Then it takes the git diff of your branch and the latest master and checks all the files that have changed. The first thing it does is we have a folder structure, so it's like our services are source and then some name of a service or shared, and then we have like the source code for everything. And first off, we just check, does, for example, source Jarvis, is that a file that has changed somewhere? If so, then this service has changed, and we need to keep that in a list of things that have changed. Next thing it does is it checks package.json. Did that change? And if it did change, it checks for every development dependency and sees if any of those have changed. Like, have we bumped the target? If that happens, we always roll everything, because we use Babel and Flow and ESLint and stuff like that. And if a development dependency updates, it could potentially break our tests or our build or something like that. So we always deploy or test or run everything when a development dependency updates. Otherwise, we check if it was a dependency, we check what services depend on this and like update those. So if we, for example, update React Date Picker, there's only one service that depends on it, so the others won't get touched. And lastly, we check did any shared code change, because as you can see here, Jarvis depends on our shared server. So if we update our boilerplate for the server, we want to deploy all services that depend on that one. So it's that simple. You only have to like read your git diff and check for these things. It's not more than that. So the benefits that we get from this is that now we have, throughout all of our web projects, consistent code style. Because we have only, in our shared code, we have ESLint, StyleLint, and Flow configs, and Babel configs, and Webpack configs. And these are all shared through all services. So they all run exactly the same. We use Greenkeeper, which is a service that provides you with an automatic pull request as soon as a npm dependency that you use is updated. So if React updates from 15.2 to 15.2.1, we get a pull request automatically. So this keeps all of our projects up to date by default. Even though we're not working on them, they're always up to date. So Kotson, actually, I have to give him huge kudos because he took the 2014 editor and put it in there, and now it's actually up to date. And if we're going to work on it, it's not the most sophisticated stack, but at least it's up to date and we know how the API works. A great thing about this is code is shareable by default. You're writing it in the same repository as everything else. So if you want to share it in another project, it's there. You can just use it. You just import it. And like bootstrapping a new service, if we want to do yet another web, it's as simple as you just create a new folder and start writing code. You probably want to copy paste some of the like React setup and stuff like that, but it's as soon as you have a new folder, you have a new service, and it gets deployed automatically. We don't have to do anything about it. And also, like all boilerplate code, like I said, we have server, Redux setup, React setup, Webpack, Babel. All of this is shared in a single place. So if you update any of this, it gets deployed to all services automatically. And like the biggest plus side for rapid growing companies to try this out is it's super easy to onboard new people. You have one project, they only have to clone one project to set that up, and in our case that's just clone it and run npm install and you're ready to go. So as soon as you try working on one of your webs, he knows all of the others because consistent code style, it's everything is the same. And your deployments are the same, and like your pull request will be the same, and it just works. So yeah, that's it for me. Any questions? Yes?
Do you share components throughout the code base, or is it just like services stuff?
Question was, do we share components? Yes, we do that. So we actually tried out the other day. He created a topic search picker, so you could like search for a topic and it would be injected for an internal tool. And what he did there was pretty cool. He created a shareable module, which was the topic picker, and he created a reducer and actions and API and a component. So you only have to import this one thing and put it into your reducer, like root reducer, and then you're ready to go with the topic picker, and it just works. You don't have to do anything else. So yeah, we definitely share components. Yes?
The npm auto updater didn't cause any errors.
The Greenkeeper.
Yeah.
No, we have a. Oh yeah, sorry. Does Greenkeeper cause any errors? We have a pretty good test suite, so we haven't had. Oh yes, we actually had the other day, but that was our fault. We have a good test suite, so we haven't had any issues with it yet, except for this one thing where we were using an amplitude library, and we thought, oh, okay, this is fine, but let's use it in the client. And then they updated to 3.0, and we're asking for built-in promise support, and then we found out there was a node library, not a browser library. So we reverted that, but that's the only problem we had. All right, if you have any questions or something, just come and talk to me. I'm willing to share code if anyone's interested. It's pretty heavy, so I didn't want to include it in the slides. Otherwise, thanks.